Hi, this is just a video on structs and typedef in C. So I just did a video on this if you've seen the first one. If you haven't, you can just look in the playlist for C and you can just find that video. This video is just an alternative way to define a struct with a typedef. So what's going to happen is we're just going to define a struct, and then we can create that struct into a type, and it's just an alternative way to what we did last time. Also, I'll be doing, if anyone's interested, I'll be doing a small Linux series, Linux, Unix, just a few command videos, and then I will be doing I think about three coding projects. They'll be probably maybe half an hour to an hour long. And then after that I'll get the Android video guys, the Android videos up for you guys. And then after that we'll be moving on to Python and .NET, so if you guys are interested, you can subscribe to the channel. So right now we'll just create a struct here. So we'll just say, whoops, what am I typing? Okay, so we have a struct, we're calling it a student struct. So we just named it student. We're just going to say that it has 3 fields. One is a character name, which holds an array of 128. Basically, it's bytes. So here we can say int number. We can have another field here, so int number. And then we can have a point. Basically, it's like a node within a node, so it's kind of like this struct holds another node to another student, so we could say we have a student pointer to next, so it's like next, perhaps a link. It can be like a linked list node. So here we can have, instead of just naming it here how we did and calling it with typedef struct at the top, last time we did typedef struct student, we called it something, we named it again. That way it's a little bit confusing. So here we could just have typedef. We can call the keyword typedef, tell it that we want to create a type, and say that we want to create a type of types that's a struct and it's a student. So this way it kind of makes more sense. And then again we're going to be calling it a student, so it's just the type is struct student, and we're calling it student. So what's really happening is it's really a type student of type struct. So anytime we call student, it's really this type which has these fields, and inside one of the students has a pointer to another link. So hopefully that makes sense. Each link would have its own name, number, and pointer to the next link as well. So you can have a linked list with this. So this is just a little bit more of an example. But we can say we want to create a type student here, and we can call it pointer head if you want a head node, to set it to null. Is there something wrong with that? Oh yeah, sorry. So null in this language is capitals. So it has to be capitals like that. So then here we can call another student type. And we say we want just like a new, we could have called this one tail. How about tail? And we'll set it to just, so we'll say the tail is null at this time. And we can say we just have one more that's a pointer called temp, or just temp like that. And right now that's just a temp, so perhaps if we were linking all this, we could just use we could just be using the temp perhaps to iterate through the links later on. So we could create maybe another one. So we have student. Okay, so let's just debug this and see what we have. Something happened here, so let me just save it. And try running it again. Okay, so something's wrong here. So it says must use struct tag to refer to type student. We typedefed it. So we have typedef struct student. I feel like my professor has mistakes in the notes. Okay, so maybe let me just change this to small s, lowercase. Nope. Okay, so something's wrong here. Maybe this one. Is that it? So is that line 7? Yeah, I mean, I think that would be okay. It's the same thing, really. It's just we have to put a struct keyword there just to show that the pointer is of type struct as well. So really the student pointer to next will have a char name and int number and a pointer to another struct student pointer next. So hopefully that makes sense. So we'll just click the debug icon now. Excuse me. Okay, so what's happening here? So we have didn't come up with the struct yet, so we can just step over that. So if we have a head, it's just completely null. That's all that it's saying. So let me just so we have our three students here. You know what? Is that wrong? That is I think that's wrong. Is that capital? Yeah, I think we need okay, no, that's okay. So because we named it there. Whoops. Okay, so how come it's not letting me access these fields here? So we have we should be able to access it. Oh, you know what? I think I know what it is. So let's say, oh great, I dropped the mouse. Okay, so let's, I think we have to use the arrow operator. So if we have pointer temp, apologize, I'm typing in the dark here. Okay, so if we have pointer temp, then we can use the arrow operator. let's see what's happening here. So we have, okay, so if we have pointer temp, okay, so let's try this. So then if we declare that here, there, and then we have a temp. There we go. Okay, so to use these, if they're a pointer, you need to use the arrow operator. So we could set like, we could say temp arrow name, name is set to like Tom or something. And we could, so we have one student like that, then we could say, okay, well the head's name is set to, just say that the name is set to Lisa. So we have head's name, and we can set, I think if we create another student here, whoops, if we have another student type, so if we have a student type without a pointer, val dot doesn't like that. Student val dot name equals not assignable. Okay, so you have to use the arrow operator to set the name. For some reason that seems to be what it wants usually, even in other situations. To reset a string, you have to use a pointer. And with the arrow operator usually. I don't think it's letting me access number either. So overall, to access this typedef struct, you pretty much just need to use arrow operators. Yeah, I don't think it likes that either. It says 16 expected. Okay, yeah, so it doesn't like that. If I just have val here and set val. Okay, so yeah, so it likes that. So you can use that if it's not a pointer. You can declare it first, then call the name with the dot operator. That'll help you access some of the fields. I don't think it'll let you access the char field still. It's going to probably want you to use the pointer. So if we just say, it might let you, so we could try it. Always just test it, so we could just say, okay, test. Okay, so it's saying it's not assignable, so the only way to access that is with the arrow pointer through, with the arrow through the pointer itself, so you have to create a pointer. Or you could have a pointer point to this val, uptype student. So we'll be doing that in the coding project. We'll be doing a lot of stuff that will just be coming into it'll be coming into first nature once you see. Sometimes you just have to move the pointers around and then you'll notice how it works. So we'll do a good example definitely to get your feet wet with all these so for all the examples, pointers, structs, all the other stuff too. Typedef, so we'll be doing a tic-tac-toe game, and we'll be doing a menu-driven writing to a binary file and reading from a binary file with a menu and options, so the user can select with loops and all that. So it's actually not very hard at all. The only thing is with the pointers, it's a little tricky, but you'll see it's really not that hard. It's not the greatest. It's not my favorite language to track all the pointers, honestly. because it's hard to track all of these pointers, to be honest. Because what I did is I actually set variables to them to actually track indexes. So if I set a pointer, and because if you want to get to the next index, you have to plus that pointer. You have to add 1 to it to go to the next index. But the thing is, a pointer doesn't tell you what number it's on, so I had to set another variable to point to that pointer, and that's an int and increment by 1. So it's like a count set to a pointer, so it's kind of annoying. So I'll show you guys next time. So we have one more field. So let's see what we can access with that. So let's just see if we can. So we have val. We have next. Next dot name. So we can continue to set them through links. So if that makes sense. Linked. Oops. So we'll just say it's a linked name. Okay, so since it's not a pointer, I might not like that one. So let's just say val.next.number is set to let's just set it to 6. Something wrong with these now. Just comment that out for a sec. So temp. Didn't these work? What happened to these? Okay, so we have temp, pointer temp, name is set to pointer value. No. Oh, that's an error there. Okay. Okay, so there we go. So we needed to was that red the whole time? I couldn't see it. I apologize. So you need to access the way to access the name, because for some reason strings are a little bit funny, or character arrays at least. They're a little bit funny, so it's hard to modify them. So we had to call the pointer value. We had to call the pointer value before the variable name. Then we use the arrow operator to point a name to change the name. So we can't change val because it's not a pointer. We can't change the name unless we use some kind of special method where we set a pointer to point to it to access it. So we'll be doing that in the coding video if we haven't done it before in the project. The binary, writing to binary files. So we showed how to link, so we can continue to keep linking that over and over again. So that's an example of a linked list. Did we set everything? Yeah, we did. So we set the name, we set the number, and we accessed the link to set the next. We called the link, and we set its number to something else. So what else we can do here? We can maybe set the pointer, the string pointer, so we could set tail. So we could say tail, do we have to use that? So we'll say tail point to next. Point to name. It might not work, so we could just set it to test. Or no, we just set it to str. It's a string. So we might need to access with the pointer value. And it works, so hopefully you guys understand. We could probably go next, and you'll have a chain somewhere. You probably want to keep track of it. So we'll just save it and debug it just to see what we have. Actually, no, that's too far. So let's just go there first. So I've set a breakpoint on 17. So right now it's telling us that we have a head node and a tail node. They're both null at this time because we haven't accessed them in our local variables. And we have temp is not null. It has a name, a number, and a pointer to another next node. Which are currently pretty much empty, just garbage right now. Because we have temp is just declared, you can see we don't have anything, it's not initialized or pointing to anything at this time. Then we have our val, which is just floating in memory. So now we have val, so we're at val.number points to 5, so we want to set val's number field to point to 5. So right now if we have val, its number is just some garbage value, so once we step over this we can see that number was set to 5. So remember, I'm debugging, and then I just click the step over button to just debug it. So now we have val.next, so we've called the val student, which remember our student has a name, has a character name, an int number, and a struct student type pointer to another struct student called next, pointer to next. So, and in that next it'll have the exact same fields and another next, so it's basically an undefined link, or it's an undeclared link, or it's a link that's just declared. Pretty much it's not initialized to anything. So right now this is the next just points to nothing or some garbage value. So hopefully that makes sense. So right now we're just saying, okay, well, we want to access our val student type, right? So now then we're going to call the next, use the dot operator to access the next node. Then that node, from that node we're going to use the pointer operator. Since next was a pointer, then we can use the arrow operator, sorry. So we can use the, since next was a pointer, we can use the arrow operator to access its number field. So now it's not val's number, it's next, the next node which val was pointing to. So it's really like the second node in the chain's number. We're setting it to 6. Something happened here. Okay, so that there's something to do with a memory error here, so we might have had to free something. Or perhaps you really just need a pointer to access those, so we'll just let's stop that. Comment that out. And what we'll do is we'll do it with tail. So we'll say tail. We'll say pointer to next. So we said, okay, we want pointer value, then tail, arrow operator to point to next, and then we want to point to number, and we want to set that to some value. Let's just say we'll set it to 1,000. Indirection operator, hold on, let me just go to theirs. Indirection requires pointer operand int invalid. Okay, so we want to access the next. So we access name, alright, so it is a pointer. Will that work? So it wasn't really giving us an error, it was just telling us that the memory was full. So somewhere along the lines you might have to allocate and free the memory. We'll try to do an example with that, so let's just try it. That's the problem with C, so let's just try to see if it works this way. So we'll just skip that, then we have the pointer to okay, so there's an error here. Okay, so let me just clear up these errors and I'll see you guys in a few seconds.